Black holes are some of the most enigmatic and sinister phenomenon in the universe. They can swallow up entire stars and planets, bending the very fabric of space and time. But what if Earth, our home planet, were to be caught in the grip of a black hole's event horizon? What would we see before the inevitable end? Well, let's have a look-see, okie dokie. So a black hole is like the bully on the playground. You avoid them at all costs. It's a region of space where gravity is so strong that nothing, not even light, can escape it. It's like Houdini in reverse. As with snowflakes, every black hole is unique. Each one has its own mass, spin, and charge. And they also come in different sizes, sort of like jeans. Petite, slim, regular, and husky, or something. Anyway, there are 4 sizes. The smallest black holes are the stellar mass kind. They're born when the massive star runs out of juice and folds in on itself. They're like the chihuahuas of the black hole world. They may be tiny, but they're feisty. They gobble up nearby matter like a hungry puppy. And even the smallest one is 3 times more massive than our Sun. Next up, we have the middle children of this cosmic family, intermediate mass black holes. They're too big to be born out of collapsed stars. Scientists believe that they may be created when several black holes merge into one. And even though they can't dominate galaxies, at least they can swallow up some nearby stars. Goody for them, huh? But do you know who can dominate a galaxy? The enormous monsters of our universe, supermassive black holes. They're the giants with masses ranging from millions to billions of times that of our Sun. And they play a crucial role in the growth and formation of their host galaxies. Finally, there are ultra-massive black holes. Trust me, you can't even imagine the size and mass of these guys. These cosmic eldritch horrors are extremely rare, but the ones we know can devour entire galaxies like Pac-Man. So, what happens if you get too close to a black hole? Or more like, what would you see in your last moments? Well, first, you reach an event horizon. It's like a point of no return, an invisible boundary that marks the edge of a black hole. And here's where things start to get really weird. For example, time starts to slow down. Not for you, for an outsider watching you from a safe distance. If you were falling into a black hole, you wouldn't feel any different. But if you were watching someone else fall into it, you'd see them slow down and eventually freeze in time, like in a paused video. As you get even closer, you would start to see some pretty mind-bending things. The gravity would cause the light around you to bend and distort, creating a sort of funhouse mirror effect. You might even see a halo of light around the black hole, known as the photon ring, or jets of high-energy particles spewing out from the black hole's poles. You can actually get pretty close to a black hole without feeling any major effects. It's only when you cross the event horizon that there's no going back. Your goose is cooked. After crossing this boundary, you'd be unable to see anything. For the person watching you from the outside, it would be as if you had suddenly disappeared. Meanwhile, you might start feeling a bit stretched out, like a piece of spaghetti. This is because the gravity is so stark that it's pulling you in different directions at once. There's even a scientific term for it, called spaghettification. We'll cover linguinification in another video. Now that you're inside a black hole, you're taking aim at the singularity. It's a point of infinite density in its center, where all matter is crushed down to a single point. It's like trying to fit an elephant into a tiny matchbox. Everything gets squished together until it's as small as it can possibly be. Which means it's time to wave goodbye, I guess. And if all that sounds scary, here's another fun fact. Black holes are not rare at all. Actually, there's one in the center of each galaxy, including our own Milky Way. So, does it mean that we'll eventually be sucked into it? And if so, how exactly would it happen? Well, let's see. Imagine a black hole approaching our solar system. At first, it appears as nothing more than a tiny speck in the distance. But as it gets closer and closer, its gravitational pull begins to wreak havoc around. Planets start to veer off course. asteroids are flung into oblivion, and comets are shattered into a million pieces. But just like waiting for the sausage to be served in a German restaurant, the worst is yet to come. Yeah, like that joke. Soon, it inevitably reaches the Earth. First, our planet's atmosphere would be pulled toward the black hole, triggering a massive windstorm. And there would be huge waves on the oceans, the water itself being distorted by gravitational forces. Imagine seeing seas and oceans getting stretched out. Earth's magnetic field is generated by the motion of molten iron in the planet's core. But now, the extreme tidal forces of the black hole would disrupt this motion, causing the magnetic field to weaken and distort. All this would cause massive earthquakes and volcanic eruptions as the planet's crust and mantle were pulled apart. All infrastructure and technology would be completely destroyed. Buildings, bridges, and roads would be torn apart. Okay, let's hit the pause button. Pretty horrifying, isn't it? Nah, but don't worry. You wouldn't have even seen that much, because you would have felt the effects of the black hole much, much earlier. Well, back to the future. We'll lose our magnetic field even before everything started to collapse. And this means not only that the weather and climate will become terrible, we'll also be exposed to extreme radiation. These gamma rays and the heat from the black hole could drastically change our planet. Say ta-ta to all our beautiful nature. At least misery loves company. We won't be the only ones affected by a black hole, which is probably even worse. As this beast engulfed the entire solar system, it would consume about everything. One immediate effect would be the disruption of the orbits of asteroids, comets, and all the other bodies. The planets would begin to deform and stretch, their surfaces warping like molten metal. The sun itself would be affected, its surface contorting like a glob of putty. And yeah, all this is scary even to imagine. But now, breathe and relax, because none of this will ever happen. This is the bright side, remember? Your infinitesimal odds of winning the big lottery are even better than the Earth ever being swept into a black hole. The nearest black hole to our solar system is called Gaia BH1. Discovered by scientists in 2022, it's found in our own Milky Way galaxy, about 1,600 light-years away from Earth. Gaia BH1 is about 10 times the mass of our Sun, which makes it a stellar mass black hole. It's not very interesting on its own, but its discovery has supplied valuable insights into the behavior of these cosmic monsters. But as you can see, even the closest known black hole is over 1,000 light-years away. They move very slowly, and they'll never get so close to our system to pose some kind of a threat. Hey, but didn't you say there's a black hole in the center of the Milky Way galaxy? Doesn't that mean it's going to eventually hoover up our entire galaxy, you may ask? Maybe not in that voice. Well, don't worry. The correct answer is no. The one in the center of our galaxy is called Sagittarius A star. You may remember it from that viral blurry photo that circled around the internet a few years ago. This black hole is indeed very massive and has a strong gravitational pull, like two 8th graders in love. However, it's still a small beam. It only affects objects that are close to it. The objects in the galaxy are all too big and move too fast to be pulled in by black holes. Nevertheless, they're still fascinating objects to study. Scientists are still trying to unlock the mysteries of black holes. And even though they'll never be dangerous to us, they're still a huge reminder of the incredible power of our universe. Now I think I'll turn my attention to the incredible power of chocolate.
As soon as the Earth is cut in half, almost all living creatures will come to an end. An apocalypse will begin, which has not been shown in movies. The atmosphere is damaged, the magnetic field will change, and the planet's landscape completely alters. But the planet will be completely renewed, and life, like a phoenix, will be reborn from the ashes. A super powerful laser would be needed to separate the planet. Such a laser has to receive energy directly from the sun. The weapon goes into space on a rocket, thousands of miles above our world. Then, once the laser arrives at its destination, it opens wide to expose plates of solar panels. The laser absorbs and concentrates the sun's rays, Then a powerful energy beam with the diameter of several cities shoots into the middle of the planet. Oceans through which the beam passes boil and evaporate from the high temperature. These vapors turn into a vast thundercloud in the sky. A strong wind drives these clouds over the continents. Heavy rain falls, which floods not only cities, but entire countries. As the tectonic plates shift, tsunamis are created. Huge waves crash onto the shore. The Earth is split in two. And this is just the beginning. The structure of the Earth, or rather, each half of it, is changing. Strong earthquakes occur all over the world. The worst disasters happen near the fault line. Billions of tons of ground are smashed. Massive landslides drag entire cities below. Chunks of land, thousands of miles in size, shoot away from our planet. All living creatures on these pieces of land fly into outer space. Other broken pieces of the planet land on the half that is closest to them. Imagine a huge rock the size of a whole city falling from the sky, and there will be hundreds or thousands of such stones. Those who live far from the cut site have a chance to survive, but even there, earthquakes will destroy houses. The moon will also start to throw off pieces from itself. These pieces, like a meteor shower, will fall onto the Earth halves and create massive explosions. These explosions will create fires. The skies will be covered with ash, and until it settles, we won't be able to see the sun. Both parts of the planet are drifting away from each other. The red-hot heart of our Earth is right in the center between the two. This is the Earth's core, consisting of molten metals. Each half of the core exudes energy comparable to a star. Between the two parts of the planet, a layer of such hot space is created that nothing can survive there. Any item that falls into this space immediately turns into ashes. The mass of the core is much larger than the ground mass, so there's a higher level of gravity. The core sucks in everything that comes close. You can't travel from one part of the Earth to the other. The core's gravity attracts any shuttle. Each half of the Earth now lives on its own. Typically, the core inside our planet rotates and creates the Earth's magnetic field. This field is a shield that protects us from the sun and space. If the shield is damaged, solar and cosmic radiation passes through the atmosphere. Because the core is divided into two parts, the Earth's magnetic field becomes unstable. Power outages begin in both parts of the planet. Microwaves, TVs, kettles, traffic lights, computers, everything is broken. The screen of your laptop or phone starts turning on and off. The video may freeze and the battery runs out and charges in 1 second. Satellites stop working, which means there will be no more GPS. High-frequency radio waves used for communication stop working, which means you can't make calls and send texts. In fact, all power plants may sink underground or be flooded because of the earthquakes, so there might not be electricity at all. Some people are sensitive to solar storms and experience severe headaches. When the magnetic field is damaged, the surviving people and animals will suffer from severe migraines. Scientists will have to invent special helmets to protect people from the sun. For full protection, people will have to live in underground cities. Compass needles no longer point north. They just spin in different directions. The birds go mad. They don't know where to fly to wait out the winter because the south no longer exists for them. All animals stop migrating. In the sky, planes can't navigate. Plants and flowers can't grow naturally thanks to the increased radiation from the sun. Livestock are poorly fed. The quality of products deteriorates. There's famine. The main goal for people on each half of the planet is survival. In some places, closer to the fault, the Earth's atmosphere is completely damaged. The conditions there will be similar to those in space. There is no air or heat. Only in a spacesuit can you stay in this territory. Unfortunately, you won't be able to jump and fly because gravity still works. Besides, it's gravity that becomes the salvation of our planet. both parts of the Earth won't fly away from each other because of the force of gravity. Instead, they will rotate and start to attract each other. In 100,000 years, both parts of the planet will reconnect once more, and the Earth will be completely renewed. Since the core is molten metal, it will return to a single heart, but it will take much longer to connect the solid rock of the halves. A scar forms along the entire fault. The scar will be overgrown with forests and flooded with oceans, but there will be strong earthquakes in some places near this scar. By this time, all living things have probably disappeared. On our planet, conditions are about the same as 4.5 billion years ago. Seas and oceans boil, lightning strikes everywhere, tectonic plates change their shape, and lava flows from volcanoes in a rapid stream. The Earth looks like a vast boiling pot, inside which life is gradually created. Because the Earth has decreased in size and the core hasn't changed much, the gravity will be different. On land, it will be more difficult for an ordinary person to walk. They will weigh much more. In such conditions, new, previously unknown life will be created. Today, the world's atmosphere and oceans are polluted, the population is increasing, and glaciers are melting. In the future, things could be much worse for our planet. In 1,000 years, when humanity has mastered space travel, we may decide to change our residence. We'll start looking for other Earth-like planets, and maybe we'll find something. However, nothing compares to our first home, and humanity decides to cure it. Perhaps we'll come up with the idea to divide the planet in half and live on one side. And after 100,000 years, we can come back to a new healthy home. What if you divide other planets? Since they don't have a magnetic field, they won't be as affected. For example, Venus and Mars have no seas, oceans, or lakes. Some scientists think they're entirely dried up because the magnetic field has disappeared there. This led to the complete destruction of the atmospheres of these planets. The solar wind blew across their surface with such force that it dried up all the liquid. The Earth's atmosphere reflects this wind, so thankfully, we're safe. There would be no significant cataclysms on other planets, except for earthquakes. Like Earth, the two parts of each world would simply rotate until they reconnect once more.
Okay, stay with me here. If you gathered together and weigh all the spiders in the world, you would get 250 million tons of arachnids. Wait. Before you run away, for comparison, the Titanic's weight was 52,000 tons, and the Great Pyramid of Giza is as heavy as 6.5 million tons. Well, you're right, that doesn't make me feel better either. But on we go. The biggest spider people know about is the South American Goliath bird eater. Yeah. This brown, furry, puppy-sized arachnid usually has a foot-long leg span. Its body is the size of a large fist, and its weight is more than 6 ounces. When the creature's moving, it makes bizarre, eerie sounds. They're the clicking of the spider's feet. They have hardened tips that hit the ground like a horse's hooves, just not as loud. If you see this imposing creature in the rainforest and come close to it, you might notice it rubbing its hind legs against its belly. How cute, that would be your first thought. But then you'd scream in pain. This spider protects itself by sending out clouds of hairs that have microscopic barbs on them. If they got in your eyes and nose, they'd be super painful and itchy. These hairs would also stay there for hours or even days. Now, that sounds extremely unsettling. But imagine what our planet would look like if spiders were the size of jeeps. The world occupied by giant arachnids is a dark and gloomy place. It's also dangerous. You can't let your guard down even for a second. Your enemy is lightning fast, hungry, and cunning. Normal-sized spiders eat 880 tons of insects each year. But in your world, huge monsters need much more food to live. Spiders roam the planet, gulping down pretty much any life form they see. If people gave up and didn't fight them, Earth would turn into a lifeless, barren land within a year. Up to 6% of people all over the globe have arachnophobia, extreme fear of spiders. But if these creatures were that much larger, this number would be way bigger, you think? Picture a creature more than 5 feet tall with a leg span of 14 feet. The spider's covered in coarse, thick hair, which makes the animal look disgusting. Its body is divided into 2 parts, separated in the middle by a slim waist. A set of massive jaws, terrifyingly long and sharp fangs, and 8 spherical eyes, as huge as basketballs. But the creepiest of them all? Spiders without eyes. They live in caves and other dark places. If you meet such a specimen, your reaction won't be fast enough to escape. These creatures compensate for their lack of vision by feeling vibrations. They also have an astonishing sense of smell. Terrified of spiders, people constantly invent new ways to get rid of them. Being caught by a creature several times your size is everyone's biggest nightmare. One of the scariest things about spiders is the way they deal with insects they catch. Most of these predators don't eat their prey whole. At first, it gets cocooned in silk and injected with the spider's digestive fluid. It paralyzes the prey and makes its insides liquid. That's not good. Then the creature pulls everything edible into its stomach through the hairs covering its mouth and pincer-like jaws. In other words, once a monster spider gets you, there's no way to escape. Oh, and don't forget about horrifying spider webs. Who hasn't ended up with their face covered with sticky threads at least once in your life? In your new reality, though, spotting a web in time means getting a chance to survive. Even regular-sized spiders can create webs that cover trees and houses and stretch over rivers for 80 feet. That's why if a new world creature chooses your house as its new home, it's easier and safer to move out as fast as you can. People have found a way to deal with giant spider webs, but how they do it depends on which species has created it. If the web was produced by a spider that's more active at night, people destroy them with help of UV lamps that replace sunlight. The webs made by spiders living in dry areas are afraid of liquid. Those from humid environments don't like getting dry, and so on. Another problem. One day you may come home and discover a huge monster, or 50 of them, living in your basement. Okay, admittedly, you're likely to spot these creatures before they reach any impressive size. They'll be too loud to go unnoticed. Spiders don't give birth to their babies. They create egg sacs that can contain hundreds of eggs. If such a sac somehow ends up in your home, you've got a problem on your hands. In a couple of weeks, those eggs hatch into baby spiders. After that, it can take from 2 weeks to 1 year for the babies to reach their full size. Oh, by the way, people have figured out how to use spider webs. The silk they're made of is very light. If it was a tiny regular spider, a strand of its silk long enough to circle Earth would weigh a mere 18 ounces. In a spider, dozens of times larger. Silk threads weigh more, but they're also much stronger. They can withstand extreme temperatures from -40 to 430 degrees Fahrenheit. People know how to collect spider silk. They use this material to make ultra-strong ropes. Almost all fabrics in the world are made from spider's threads. Wear-resistant and lightweight clothing, seatbelts and parachutes, bottles and cups, surgical threads and bandages, rust-free panels on cars and boats, artificial ligaments and tendons, all thanks to spiders. But probably the best thing about silk, it's biodegradable. Earth has become a much cleaner place since people started using this material in production. Along with using spider silk threads, people also gather the glue covering the webs. It's a unique substance. It stays wet in the open air and is still sticky after having trapped several insects. Up close, this glue looks like tiny beads on a string, or rather golf-sized balls on the rope if we're talking about car-sized arachnids. They produce much stickier glue than good old regular-sized spiders. That's why, in most cases, it replaces hammers and nails. All kinds of vehicles and vessels are built with the use of spider glue. The only drawback of this sticky substance, you have to be extra careful while gathering it. Once you get trapped, it's a tricky feat to escape. That's why people go glue hunting in large groups. But even if you get into a spider web by accident, there's a chance to survive if you're fast enough. Moths and butterflies have a special layer of scales on their wings. They can shed this layer if they get caught. Use this trick, take off your clothes and run for your life. But how come spiders don't get tangled in their own webs? These arachnids can spin sticky and non-sticky silk. They avoid walking on the sticky parts of their webs. Plus, they have special movable claws on their feet. These claws grip and let go of the threads when they're moving. Also, spiders' feet are covered with thousands of hairs. When they walk, these hairs create countless points of contact between the animal and the surface. That's why you can see gigantic spiders lounging on rooftops or climbing skyscrapers. By the way, when the terrifying creatures do move, they do it at breakneck speed. The giant house spider is one of the fastest spider species in our world. It can move at a speed of almost 2 feet per second. That's more than a mile per hour. But creatures as large as a Jeep can speed up to 50+ miles per hour. In other words, you wouldn't be able to escape from them by driving away. In the giant spider world, people have to install tons of artificial lights. Dense, thick spider webs are everywhere. They appear throughout the night and cover large areas, making days dim. Trees and not-so-sturdy constructions often collapse under the weight of spider silk. Luckily, it's just an imaginary world. Spiders can't grow to be as large as a car. Long story short, their hormones prevent these creatures from becoming larger than they're supposed to be. Whew! Imagine a 10-story high wall of water with a foamy white peak smashing into the shore. That's the mental image we all have when we think of tsunamis. But is it accurate? And if it is, why don't daredevil surfers ride them? That's a huge wave begging to be caught. Fear of heights, top speeds, because they choose life? Don't want to smack right into a building when that thing crashes into the shore and floods through the streets? But they're supposed to be daredevils. And how cool would it be if you, with your cheeks flapping in the wind, could ride that tsunami right into your 10th floor apartment? Just don't forget to leave the window open when you head out. No, seriously, where would anyone get the idea to surf a tsunami? I know where. Movies. All those disaster flicks depicting tsunamis as monstrous waves. It's like they cut that wave from a summertime fun surfer movie, pasted it into their own, and blew the image way up. And don't forget about that blue-gray filter. There we go, our disaster tsunami blockbuster is ready. Leave it to the filmmakers to overlook the details. Realistically, the difference between tsunamis and surfing waves is as ridiculously huge as that movie wave about to take out that skyscraper. You can surf on a massive wave, as long as it's the right kind. And that surfable kind can even be bigger than tsunamis. Some surfers ride them every year, but I'll get into that a bit later. So, what is the difference between this right kind of wave and tsunamis? Well, in surfing, every wave has a face or wall. That's the sweet spot each surfer looks for to ride down from. Like going downhill on a snowboard, only you aren't strapped to the board and there's always an avalanche behind you. And there could be sharks right under your feet, waiting to clean up whatever's left of you when you wipe out. Sorry, that got a little, terrifying. Surfing's fun, but I'll watch from the beach, thanks. Tsunamis aren't like this at all. Imagine a tsunami more like a giant tide that comes in a matter of minutes. Yes, the water will likely rise 30, sometimes 60 feet higher than it usually does. But it won't do it as a wave with that much needed wall. It'll be something like a hill of water that rolls in. Think of it like a giant gloopy lava traveling over the shore, only faster. No, even faster. Wait, that's even more terrifying than the shark thing. Never mind. For a normal surfable wave to appear, all you need is the wind to blow. Tsunamis, however, are born by some relatively rare events like earthquakes and underwater volcano eruptions. This is also where the difference in force is coming from. Tsunamis aren't always bigger than regular waves, but they are much more powerful. So every time they come, they tend to bring disaster with them. When an underwater earthquake happens, it produces unbelievable amounts of energy that literally punches the water. This energy has to go somewhere, and that somewhere is towards the shore in the form of a tsunami. In fact, next time you're doing the dishes and in need of some fun, you can make your own mini tsunami. Just place your hand fully underwater and move it up and down, even just a little bit. You'll see ripples on the surface. This is what happens in the ocean after an earthquake, but on a much larger scale. Tsunamis gain incredible speed from the ocean bed moving or shifting up to 200 miles per hour. So those things hit land going as fast as an arrow through the air? Well, that's why I said cheeks flapping in the wind as you ride that gnarly wave. But no, seriously, they aren't going nearly that speed when they crash onto the shore. They lose a lot of that energy as they meet the rise of the ocean floor near the coastline and any underwater obstacle in their path. When you surf into your apartment window, you'll only be going about 30 miles per hour. They might slow down, but the wave grows bigger as it gets closer to the coast. Mega tsunamis are those 100-footers that'll get you into your 10th floor flat. The average height for most is only about 10 to 30 feet. Yeah, only. Compare that to a normal surfing wave. It's usually 6 feet high and only goes about 13 miles per hour. That's why tsunamis are still fast and big enough to cause major damage. But the surfing ones are no walk in the park either. Those kinds can be dangerous too. Just like tsunamis, wind-driven waves will rise when they hit an underwater obstacle near the shore. This obstacle, be it an underwater ridge or coral reef, is the main source of danger for surfers. If a surfer can't hang, they'll be dragged into the deep where sharp reefs lie. That and hitting the water doesn't exactly feel like a gentle pat on the back for a job well done. Okay, I get it. You can't surf a tsunami. But we're in what-if territory, where the rules don't apply, and my imagination likes to run wild. So let's have some fun tackling this challenge. First things first, since the tsunami isn't a usual wave, we need to find a way to turn it into a surfing spot. You know, somehow get it to form a wall. One thing that could work is an artificial obstacle under the water that'll be specifically designed to strip the tsunami of its monstrous energy. Sorry, we'll lose some of that epic speed, but we need to make it rise higher. The obstacle will have to be a massive structure, but still deep enough that our surfer doesn't bog his head if he wipes out. Next, we need to take further safety measures. In this case, some sturdy gear. Typical surfing wetsuits are made of neoprene, a flexible material that can protect you only from cold water and help you stay afloat. But lucky you! A new technology recently emerged, a wetsuit that can resist a shark bite. It's like Kevlar vests in a way. All the tests show that it can't be punctured with sharp objects, and it prevents bones from breaking. Unfortunately, bruises from blunt impact are inevitable. It's tsunami surfing we're talking about after all. And finally, the board itself. If riding a normal surf wave is a fair challenge of your sense of balance, then keeping yourself on that board while riding a tsunami might just be impossible. Remember what if? Okay, let's throw some stabilizers on that bad boy. There, now you're ready. You're ready, aren't you? Don't chicken out on me now. Come on, people have done this. They do it all the time in Nazir, Portugal. Well, they don't surf tsunamis, of course, but big wave pro surfers go there every year to challenge Nazir swell. And this 30-foot tsunami you're about to ride is just a pup compared to the biggest wave ever surfed. It was 80 feet high, more than twice the height of a telephone pole. Brazilian pro surfer Rodrigo Coja broke this record in 2017. Maya Gabeira set the women's record by conquering a 68-foot wave in 2018. And I don't think that's the limit, because waves in Nazaire can reach 100 feet at times. Hey, the reason why waves in Nazaire are so big lies deep underneath the ocean surface. This place has one of the largest underwater canyons in Europe. It's a 140-mile-long, 3-mile-deep gash in the seabed that pushes insane amounts of seismic energy to produce massive waves by the time they hit the shore. The canyon alone triples wave heights here, but there's also strong ocean currents and powerful swell winds in this region. So, it's like the perfect storm for surfers who like a real challenge. Monday morning. The alarm is ringing cheerfully, and you vaguely remember you've already hit the snooze button, maybe not even once. You force your eyes open into narrow slits and look through the haze at the clock. 5:30. 5:30? You leap out of bed, sleep driven from your brain with an electric jolt. Work starts at 9, and you'll definitely be late already, but you may yet make it before lunch if you hurry. The kids are still asleep, of course, all 6 of them. Rushing through the house but trying to be as quiet as possible, you put on the first clothes you take out of the wardrobe and walk out of the apartment. On the elevator landing, there's already a crowd of sleepy people. Even 8 cabins aren't nearly enough to accommodate everyone in the morning. You take your place at the end of the line and wait. 2 elevators arrive, half full already, taking in about a quarter of the people on the landing. It takes another 10 minutes or so for you to finally cram into a cabin and start moving down from the 42nd floor. You feel bad for those living below. They have to wait even longer. It's 6 a.m. when you leave the apartment building and join the rushing crowd outside. As usual for this time of day, there's a huge traffic jam on the road nearby. The crowd of pedestrians is too big, so you have to walk slowly. In about an hour, you get to the subway and stand in line to get inside. It'll take another 40 minutes or so. Still faster than walking all the way to the office or driving. Underground, you have to wait for your turn to hop inside the train. They come every 5 minutes, but there are so many people that even cramming doesn't help. You only manage to get on after another 20 minutes. The doors catching the hem of your jacket. You stand flat against the doors, pushed into them by the press of the people. At the next stop, you have to get off the train to let others out. But when you try to get back, you're pushed by the crowd waiting to hop on and miss your place. Come on! The doors close and you wait another 5 minutes, pressed from all sides by anxious commuters. When the train arrives, you work your elbows urgently to get inside. Got it. You prepare for a long ride ahead. There's a similar ordeal awaiting at the next 4 stops. When you finally get to your station, you're already exhausted. It's 9:20, you're late as expected, and there's still some way to go. A crowd of late runners like you is even larger in the city center, so you take a deep breath and dive in. People are going different ways, so you have to push through, which makes the going painfully slow. If the streets were not so busy, it would take you no more than 15 minutes to get to the place. But in this mess, you spend an entire hour brawling your way. At last, at 10:30, you're at the entrance of your building, Demos Inc. Despite it being one of the biggest office buildings in the city, there's a line to use the 6 elevators as well. You roll your eyes and set to wait another half hour just to get to your floor already. Wow, you're in the cabin. What a relief! You press the button with number 33 on it and wait. Again. It's 11:03 a.m. You've been awake for almost 6 hours, and yet you've only just arrived at your workplace. Your colleagues are zooming around the floor like ants, and you carefully make your way to your cubicle. At least it's near a window, and you have a great view over the town. You look outside and see the familiar picture. Rows upon neat rows of skyscrapers, most of them apartment buildings combined with offices. It's been over 50 years since the anomaly happened. No one knows where it started exactly, but people began having quadruplets and even quintuplets much more often than usual. And strangely, it seemed to only affect this city and its suburbs. In the first decade, some decided it was something in the air or water of the town and moved to other places, but it turned out everyone who was born here was affected already. Even those who moved to other countries later reported to have up to jaw-dropping 10 children all at once. And not everyone wanted or even was able to leave town, so something had to be done. That's how Demos Incorporated appeared. Its mission was to both help the city adapt to the new circumstances and investigate the cause of such a birth anomaly. And the measures taken were drastic but efficient. First of all, the corporation invested into real estate development. Bigger families needed more space to live comfortably, so new apartment blocks were built with more rooms and more spacious interiors overall. People were offered to sell their old apartments and houses in favor of newer places to live, and most of them gladly agreed. There was a downside too, though. Those who didn't want to move soon found themselves surrounded by huge construction sites. Eventually, they couldn't stand the noise and dust and agreed to sell their dwellings. The whole city started transforming. Old buildings got demolished to make way for new, taller, and bigger ones. Roads were broadened for transport to move more freely. New businesses were opened to give jobs and services to thousands of new citizens. But that wasn't enough. Population growth was more rapid than city development. Thousands left, but millions stayed. The initiative to restrict birth was met with a massive civil protest and discarded. As a result, even with hundreds of skyscrapers, the city is terribly overpopulated. Its area has grown massively since the anomaly began, and now it's the largest city in the world, not only by population, but by area too. Working conditions have deteriorated as well. More and more people look for jobs that can be carried out from home because of incredible traffic jams. Others have found work in their own or neighboring apartment buildings. Yet others still, like you, are not so lucky. They have to wake up early in the morning just to get to work on time. It's not uncommon to have an alarm set for 4 a.m. At this time, it's relatively crowdless in the streets. Naturally though, nursing and tutoring have been booming all this time. Since every parent now has at least 4 kids to raise, they accept any help they can get. Single people earn good money babysitting for their neighbors and tutoring their kids of school age. Schools, by the way, have been built at an astonishing pace, yet still there aren't nearly enough of them to accommodate all the children. Parents register years ahead of time for their offspring to get elementary education. Entertainment has been hit hard as well. Numerous new restaurants, cinemas, theme parks have been opened within and beyond the city limits. But ordering a table or buying a ticket is a game of incredible chance. With the city population grown tenfold, you must plan your weekend at least 2 weeks ahead. And even going to the countryside for a picnic is an adventure in itself. First, you have to leave the city. Then, find a spot where there won't be crowds of nature-goers like you. And after you're done, it's a trip back home. Normally, people prepare for at least a 2-day stay in the country, because it takes 3 hours just to leave the town and another 3 to get back. Lost in thoughts about all this, you don't notice your colleague approaching you and start when she touches your shoulder. She smiles and apologizes, and you notice a folder in her hand. She traces your gaze and puts the folder on your table, opening it. Inside, you see some documents, but don't understand what they're about. Your colleague points to several paragraphs, and you have to read them 3 times before realization dawns on you like a hammer. It's a set of reports from several cities across the country. There are lots of numbers you can barely understand, but all of the papers have one thing in common. They end with a request for Demos Inc. to open a branch in their respective towns. You count the reports. 17. 17 new cities have just experienced the same baby boom you've been trying to cope with for half a century. Okay, imagine there's a huge hot ball hidden inside the Earth. It's floating in an ocean of molten metal. This ball also spins on its axis, but it moves faster than the rest of our planet. This is what the Earth's core looks like. The solid metal ball is the inner core, and it's 750 miles thick. That's roughly the distance between New York and Chicago, and the whole thing is made up of hot iron and nickel. The outer core is the molten ocean. To reach the edge of it, you'd need to dig a tunnel into the Earth that was about 3,700 miles long, but you would hardly want to go there because it's the hottest point on the planet. The core temperature is 11,000 degrees Fahrenheit. That's greater than the surface temperature of the Sun. Another incredible thing about this place, the gravity at the outer core is 3 times stronger than that at the Earth's surface. This means that if we could somehow find a way to live near the core and you threw a stone there, it would fall 3 times faster than normal. It would become 3 times heavier. You would also become 3 times heavier. Now that doesn't bother you so much because things far worse will soon happen. Living conditions in the core would be the exact opposite of life on the International Space Station, and it'd be a lot harder than living on the surface. It would be difficult for you to even hold a fork in your hand because of just how heavy it would feel. Eating lunch would become a serious challenge. You'd break into a sweat just from writing with a pen on paper or typing on a computer. But if people could ever get used to these conditions, they'd become a lot stronger. Humans have learned to use the heat coming from inside the Earth as a source of energy. Some companies use this energy to heat water, which creates steam. This steam is used to power turbines that produce electricity. If the core ever cooled down and that heat disappeared, this kind of electricity might become very expensive. Some parts of Earth might become very dark, as people went back to using candles and fires to light things up at night. And you could forget about using your electric car as well, because charging it up would be just too much money. Phones, computers, the internet, all these things would cost a lot more. But this would actually be the least of our worries. Oh, just wait for it. The hot core's rotation creates the Earth's magnetic field. This field is like a shield that protects us from the sun and outer space. If the shield disappears, solar and cosmic radiation would pass through the atmosphere. The electricity supply would become seriously unstable. Microwaves, televisions, kettles, traffic lights, and computers could all be damaged. The screen of your laptop or phone would turn on and off randomly. Videos could freeze, and the batteries could run out in a second. Satellites would stop working, which means there wouldn't be any GPS system to rely on anymore. Say goodbye to navigating with your phone's map. Radio equipment would also stop working, so you wouldn't be able to make calls or send messages. Even now, when our magnetic field is working normally, solar flares can still create magnetic storms that disrupt electronics and affect people's health. Some people are sensitive to these storms and can get really bad headaches. If the magnetic field disappeared completely, every person on the planet, along with plenty of animals, would get seriously painful migraines. Scientists would have to invent special helmets that protect people from exposure to the magnetic storms. If the core cooled down and you became lost in a forest, it would be really difficult for you to find your way home even with simple equipment. Without the magnetic field created by the active core, your compass needle would no longer show where north, south, east, and west were. You would see the birds in the sky going crazy. They wouldn't know what direction to fly in for the winter, because south would no longer exist. In fact, no animal would be able to migrate anymore. In the sky, the location devices on planes would stop working. That means no more air travel until people find a new way to navigate. But hey, let's look on the bright side, because that's what we do here. You wouldn't have to go to the North Pole to see the northern lights anymore. Auroras would appear in the night sky everywhere. These occur because charged solar particles run into the magnetic lines stretching from north to south. But these lines will disappear if the Earth's core cools down, and the particles will light up the sky all over the world. A frozen core also means the tectonic plates will stop moving. There will be no more earthquakes anywhere in the world. But that's not as good as it sounds. The movement of these plates creates faults on the Earth's surface. They give us access to important minerals. With no more movement, producing fuel could become a lot harder. The price of gas might go up. Most people would have to stop driving their cars. There would be a lot more bikes and horses on the road, maybe some llamas. Volcanoes would also stop erupting. If the core cools, the magma cools. People who live near large active volcanoes would no longer need to worry so much. But there would be a downside to this. Volcanoes contain a huge amount of useful substances and minerals. The soil around volcanoes is very fertile, which is really good for agriculture. So more people would now have to eat artificially created food. There would be big problems with the supply of natural food products. Only rich people might be able to afford that classic tomato and cucumber sandwich. But the worst thing would be the long-term exposure to radiation, which is seriously bad for our health. More radiation means that the risk of getting diseases would be much higher. People would have to build special shielding to protect themselves from solar radiation. It would be way too expensive to cover the whole planet with this technology, so we just create separate shields for each city. Just imagine the side of every city covered by a huge protective dome. In this radioactive world, movement between cities would only be possible in special closed transport. People would need to wear protective suits. You wouldn't be able to go to the countryside anymore. Anyone still living in a village or a small town without much funding would be forced to live underground to protect themselves. Plants and animals would also have problems. Herbs, flowers, and trees would receive huge doses of radiation and wouldn't be able to bloom. Livestock wouldn't be able to eat grass and hay. Milk, cheese, and yogurt would be in real short supply. Plants would have trouble producing oxygen. The magnetic field not only protects us, it protects our atmosphere. A frozen core and no magnetic shield means that the solar wind would destroy the atmosphere in a few hundred years. The conditions on Earth would be changed completely. Humanity would no longer venture outside its protective domes with their artificial atmosphere. Instead, we'd have not only our cities, but also the last surviving pieces of nature, our trees, lakes, grass, meadows, and flowers. Everything left outside the domes would turn into a scorched desert. This is what happened to Mars. The red planet has no seas, oceans, and lakes. Some scientists believe it's completely dry because its magnetic field disappeared. With no protection, Mars lost most of its atmosphere, and the sun's wind swept away all of the surface water. But of course, this is just one of many theories. This took place billions of years ago, and no one can say exactly what happened. But don't worry, our planet won't turn into Mars anytime soon. The Earth's core is cooling very slowly. It will take another 2 billion years or so before it cools down completely. What's weird though is that our magnetic field can be unstable even today. In the southern hemisphere, there's a spot where the magnetic field is weak. This place is called the South Atlantic Anomaly. Charged solar particles flow through this spot, which can cause problems for orbiting satellites as they pass through. There are some other places like this around the world, but fortunately, they don't cause us any really big problems. Good thing.
Something's moving toward our planet that could end all life on Earth. It's a regular needle, weighing about 5 grams. You're probably wondering why it's so dangerous. Can something that small really do any harm? It's hard to say, because it's moving at the speed of light, and we don't really know what will happen when it hits. That's because the idea itself is hypothetical, so it leaves us with a bunch of questions. Here's the first one. What happens to a sewing needle in space? Could it actually accelerate to the speed of light? The short answer is no, but it's not that simple. In our universe, nothing that has mass can reach the speed of light. It takes energy to make any object go faster. Since there can't be an infinite amount of energy, nothing can ever accelerate that much. So in our case, we can simplify things. Let's say that the needle is moving at 99.9% of the speed of light. That's about 186,000 miles per second, or 670 million miles per hour. At this speed, the journey from the Earth to the Sun would take about 8 minutes. For comparison, the maximum speed of a Falcon Heavy rocket is 24,600 miles per hour. And the fastest car on Earth is more than 2 million times slower than the speed of light. biggest rock to ever hit our planet was the Hoba meteorite. It weighed about 60 tons. It fell to Earth around 80,000 years ago and caused a lot of damage. Would something as small as our sewing needle be able to have the same effect? Sure it would. It's all about the energy involved. Small things traveling at almost the speed of light would have more energy in them than really big but slow-moving objects. So our speedy needle would hit the ground much harder. On impact, all the energy it contained would cause a mighty big kaboom. Everything nearby would just disintegrate. But could such a big explosion really destroy our entire planet? Let's compare this to the biggest blast humans ever made. The cloud of debris that followed this explosion was 40 miles high. It could be seen from a distance of 100 miles. About 50 megatons of explosive force was released into the atmosphere. The energy our needle would release as an explosion would be about 43 kilotons of force. That's less than what humans can cause, but it could still lead to massive damage. So if you hear on the news that something is headed for Earth at the speed of light, you'll definitely need to find some cover. Could people survive a collision like this? Well, it would be pretty scary. A dazzling flash of light would be followed by a shockwave of incredible force. The glass in all houses within a 2.5-mile radius would be smashed. Even the strongest buildings would collapse. All that energy coming from our needle would cause seriously big fires up to 1.5 miles from the epicenter. Everything at this spot would essentially be vaporized. The situation would be a little different if the needle went into the ocean. Just like a meteorite, its impact would cause a huge tsunami, but the shockwave wouldn't affect big cities, and people probably wouldn't be hurt. Although if it hit off the east coast of the United States, this tiny object could still cause flooding in New York. But other things could happen if a needle like this entered the Earth's atmosphere. Because it's moving close to the speed of light, the needle won't actually be a solid object anymore, but more like a bunch of atoms flying alongside each other. So it's possible that the needle would just pass right through our planet, the same way it would cut through a balloon. It would happen very quickly, in a split second. No one would even notice, and people would just go about their business. But here's the most incredible possibility. What if the needle hit a person? Well, there's a very small chance of that happening, just 1 in 1.6 million. Although something similar happened at least once, when 2 men in Turkey experienced rain made of rocks in 1888. But let's get back to our needle going at light speed. If the human body completely absorbed all that energy upon impact, it would just disintegrate. But there's another possibility as well. The needle could weaken the bonds between molecules and atoms in your body and pass right through them without causing any pain. You'd just feel something like a mosquito bite. Of course, it would still leave its mark. The needle would make a perfect hole in your body. But so long as it didn't go through your vital organs, you'd be fine. Plus, you could boast about your incredible good luck. The chance of a space needle hitting you is almost like winning the lottery. So it seems a needle moving at light speed wouldn't do that much harm. It might create a big crater in one spot, but the world would be all right overall. But what if something much bigger than a needle flew towards Earth? In 2013, a large meteorite entered the atmosphere above Russia. Luckily, most of it burned up before it reached the ground, but the largest piece of it that survived weighed slightly over half a ton. The meteorite exploded about 14.5 miles above the surface and lightly damaged more than 7,000 buildings. About 1,500 people were injured, but it was only moving at about 37,000 miles per hour. What would happen if it had accelerated to close to the speed of light? An object this big, moving at a speed of nearly 186,000 miles per second, would have an enormous amount of energy. Its impact would basically wipe out an entire continent. The blast wave would have such force that it would completely circle the planet and pull down absolutely everything in its path. The tsunami caused by the explosion would wash our civilization into the ocean. Humans would only survive if they made it to very deep underground bunkers. But once the dust settled and we went back up to the surface, we would find that there was nothing alive left on Earth. It would be more or less the same as when a meteor destroyed the dinosaurs millions of years ago. It's true that that meteorite didn't move as fast, but it was just as big. Of course, our planet recovered from that impact, and life returned. There is actually an object moving around in our solar system right now that could destroy half the Earth. Halley's Comet. It weighs about 220 billion tons. That's a whole lot of zeros. By the way, this comet has come close enough for us to spot it at least 30 times. The last time it could be seen was in 1986, but we'll have a chance to see it again in the not-too-distant future. Its next appearance is predicted for July 2061. If an object like Halley's Comet hit the Earth at the speed of light, it would completely change the shape of our planet. The blast would form a crater the size of Eurasia. After a blow like that, the Earth would never be the same again. Now let's talk about something that's a little more real, although it's seriously weird. Is there anything out there in the universe that can move at the speed of light? Well, almost. Scientists have discovered that some superactive galaxies can spit out hot blobs of gas the size of Jupiter. These galaxies are called blazars. When they studied the blobs, the scientists scratched their heads in confusion because the speed of these things is about 99.9% the speed of light. To accelerate something as big as a bowling ball to that speed would take all the energy produced on Earth for an entire week. So imagine how much you'd need to fire off a Jupiter-sized lump into space. The chances are that these blobs are getting all that energy from supermassive black holes inside the blazars. The hole itself absorbs tons of particles, but also accelerates others and pushes them out into space.
Wow, you're zipping through space in a large ship as big as 3 New York City Central Parks. There's a lot of commotion going on. No, it's not some alien invading the spaceship. It's a very important day. The date is January 22nd, 2700. You've just been born outside of the Earth's atmosphere. Happy birthday! There's a medical team attending to everything. Futuristic gadgets help out with every aspect. And the view from the giant spherical glass ship is nothing but the incredible vastness of space. You can't even see Earth anymore. The spaceship is flying to a new destination millions of miles away. ETA on reaching that new host planet? Decades. Fast forward a bit. You're 25 years old, and this spaceship's the only home you've ever known. So far. You've learned all the ins and outs of the ship. You start your day in your dorm, which has all the essentials: a small compact bathroom, a mini kitchen, a bunk bed, and a magnificent view of the stars and planet outside the ship's reinforced glass. And you never need to worry about space radiation. The ship has an everlasting magnetic shield that reflects space radiation, so it doesn't seep its way onto the ship. Otherwise, there'd be big problems. The ship was designed to have artificial gravity. Astronauts normally lose 1 to 2% of their bone density every month they're up in space, since they're just floating around all the time. But now, I mean in the future, in deep space travel, they're able to solve this problem. You make your way out of your dorm and see a wave of fellow crew members making their way to work. They're all gliding through on their advanced mini hoverboards, and everyone's wearing different colors, a space-age uniform. Yours is blue, so you hop on your board and join the blue wave. You get to the underpass of the space transport and begin your work. As an engineer on board, your job is super important, maintaining the ship and keeping it running. But something's wrong. Numbers are flashing all over the panels, and the dreaded red light won't stop blinking. You alert your coworkers, but they don't know what's happening either. Quick, you keep checking the logs and all the complicated equations, but nothing adds up. Panic starts to spread throughout the ship. The hair on your arms is standing on end. You try to click on as many buttons and switches as you can. The buzzing keeps getting louder and louder. The light is flashing brighter. Some of your colleagues make a break for it, and you're all alone in the red room. Suddenly, finally, your supervisor rushes down to help. After a while, the two of you figure it out. Whew, that was close. You still have a lot to learn about managing the ship. Since your early years, you were assigned to work as an engineer. You were great at physics, chemistry, math, all those sciencey things. It's just another day in the office. But on this ship, you may make captain one day. After work, you get a call from your friends wanting to hang out. And when I say call, I mean a phoneless device that lets you communicate with anyone while seeing all their info through a hologram projection that only you can see. You can also use it to listen to old tunes from Earth. Pop music has now become classical music, and movies are now 3D projections of your own imagination. You make your way out of the underpass and go up to the Space Plaza. That's where everyone hangs out when they have time off. Some cafes, restaurants, a barber shop, even an ice cream parlor. You've never hung out anywhere else. The space transport is essentially a small city which has all the important things society needs. That includes a biosphere full of animals and plants from different climates on Earth. Many tropical forests, many deserts, many rainforests, you name it. The biologists on board make sure to keep it all healthy so you feel like you're at home. Not that you've ever set foot on Earth. You enter the wild savanna and see some gazelles galloping around. A few wildebeest seem to be rummaging around, and a small pack of lions are on the prowl. In the jungle, you feel the humidity and the thick leaves and bushes all around. Some mountain gorillas are playing, and there are little tree frogs here and there. And lurking in the trees, making its way down for a sip of water, is a jaguar. Over in the dry desert, you see some roaming camels, a little rattlesnake slithering its way out of the heat, and some little scorpions crawling around in the sand. You learned a whole lot of biology these last 25 years. You know all about Earth, but you've never been there. Weird. After the tour of nature's habitats, you hear an announcement on the PA. It's the captain.
The new planet is hours away, earlier than anticipated. Everyone assume positions for landing.
Everyone on the ship rushes to their dormitories, except the key crew members needed to run the ship. You strap into your bunk bed that turns into a seat with fancy interstellar seatbelts. You look out your window and see a blue dot in the distance. It gets bigger and bigger, and it looks a whole lot like Earth, from far away at least. That didn't take all that long, only 25 years. Wonder what's going under the hood of that spaceship. You look back at your life in space, knowing this first part of it is coming to an end. It's kind of like living at the South Pole. At the bottom of the world lives a small community of scientists who work between winter and summer doing all kinds of research, from climate and geology to meteorology and astronomy. Their lives must be similar to living here in outer space. They have their own bunkers, scientific labs, and even recreational rooms for sports and music. The nature on the planet you're approaching is unlike anything on Earth. Tropical trees soaring higher than the highest skyscrapers. Oceans that are so wild, there are hurricanes that last for years, just roaming about. The pilot announces the landing. It's all good. Time to get to work. You unstrap yourself and head outside to see the new planet for yourself. Walking on land feels like, well, like arriving on a new planet. The humidity is thick and the wind is warm. The ship landed on the tropical side of the planet, where studies show is the best place to begin a brand new settlement. It's not going to be easy. Humans usually begin new settlements next to lakes and rivers. Think of the Mesopotamians, the ancient Egyptians, the Aztecs. The list is endless. They began as small settlements until they grew to be fully functioning mega-civilizations. By trading and exploring, they were able to advance their technology, learn new languages, and discover awesome cooking recipes. Hey, I could go for some pasta and sushi right about now. According to scientists, being born in space could alter the way humans look. Human heads could be bigger within thousands of generations. Who knows? There's no way to simulate it on Earth. We can even have different new skin colors, since we would need more melanin, that pigment stuff that protects us from sun radiation. Being closer to the sun or any hot burning mass of fire might mean we'd produce more or different kinds of melanin to protect us. We might turn dark brown, purple, gray, or even green. We'd have to wait a couple of million years to find out. And with no gravity, humans would have to get used to having a lower bone density, kind of like birds have. That means we'd probably be weaker than our old Earth human selves and have some slightly odd physical things going on. Gravity is essential for our balance, and mobility is one of the key factors for human survival. So, without gravity, we'd most likely have exoskeleton suits for walking and running, or taking out the trash. Now, nothing like this is going to happen for a very long time. They're still brainstorming how to bring someone into this world, or out of this world. Technically speaking, outer space is considered to be 62 miles above sea level from any continent on the world. Beyond that, endless possibilities. Hey, welcome to Earth 2050. You're living in a world after the great temperature shift of 2020. Days are as hot as they can be, and nights are just as cold. Humans have always depended on the environment, but now they're more vulnerable than ever. Fuel, money, precious metals all lost their value in a world where ice costs more than gold during the day, and you can exchange a brand new designer watch for an electric blanket at night. You don't remember the world that used to be because you were born in the new climatic era. You were lucky to find a good job right after college. The company you work for sells bottled water. When it's 100 degrees plus outside during the day, bottled water is on top of world sales. The antiperspirant business is booming too. People can easily go through 2 sticks a week. You wake up at 6:30 when it's still cold. The sun comes up in half an hour, and the shift will follow shortly after. There's a half-hour window between 7 and 7:30 when temperatures are pretty moderate, like spring in the old times. Most of the day, from 7:30 a.m. to 7:30 p.m., is like living in an oven. 7:30 to 8 p.m., it's probably like what they used to call autumn. From then on, it's 40 below. Today's a big day. Could mean your first promotion. You take a deep breath, slide your feet into your slippers, and head to the shower. On autopilot of the day-to-day routine, you first turn the sink faucet all the way off. It's an old-world habit your parents recommended to keep the pipes from freezing. Even though all of yours are up to code, wrapped in heating tape and insulated, you'd rather not risk it. You get dressed, the daily shorts, sandals, and tank top. They have high-tech thermo clothes that adjust for the day and night temperatures. But you don't have the money for those. Maybe if you get that promotion, you can invest in a good, efficient wardrobe. Funny thing is, you can always tell a person's status by looking at them. Some things never change. The thermos walk confidently with their stylish techwear. You and the rest of the baggers pack extra clothes for work and cold evenings. Got your umbrella? Doesn't help with the heat, but at least the sun doesn't beat directly down on you. Shades, deodorant, SPF, day supplies are good. Now for evening. Gloves? Check. Winter ding! You get a text message. It's your boss. You're coming in a little earlier today to set up for the presentation, right? You text her back and head to the kitchen for breakfast. Coffee's a luxury. Same goes for fruits and veggies, unless you grow them at home, but your personal greenhouse is pretty modest. Tomatoes, corn, some melons, and lettuce. The greenhouse is still cold and heat-resistant like the standard model, but you definitely need to upgrade to a bigger one. No time, too much work. You grab an apple, a bottle of water, your bag, and rush out the door. You usually leave at 7:15. It's a 15-minute walk to the office, just enough to beat the heat. But you're out shortly after sunrise today. There are thousands of people on the street. Everyone tries to stay indoors unless it's during those 30-minute pockets of moderate weather. Even with the crowd traffic, you still get to the office just in time to set up for the big presentation. You majored in water manufacturing and distribution. When you told your boss about this idea of yours, she immediately invited the bigwigs to hear you out. It could cut the price of bottled water in half and put the company in the history books. You hurry to the locker room to change into your suit. The presentation goes great, despite your nervousness. Your boss tells you big things are coming your way, but take a vacation because you'll need plenty of rest before work begins on turning your idea into a reality. You go online to see your options. People don't vacation to the beach anymore because the climate is pretty much the same everywhere. That, and you can't fly anywhere. Air travel is a thing of the past, since planes can't take off in 100-degree weather. High heat means air is thinner, so the wings can't produce lift. At least, that's what your granddad told you. He was a pilot in the times before the shift. Skiing, ice skating, and snowboarding are now done only at indoor artificial snow resorts. Now that sounds refreshing. You finish work at 4 p.m. You think about going straight home, but you're in such a good mood, you decide to go for a stroll in the park. Gotta change back into your shorts and tank first. You walk along the empty streets. Hardly anyone just hoofs around in the heat of the day. Whew! You immediately understand why. You look at the city. Short groundscapers line the streets. Skyscrapers are no more. The huge temperature fluctuation between day and night made them unstable and wore them down. Plus, skyscrapers trap heat and make the city hotter, something nobody needs in this new age. You look at the rooftops, covered in solar panels. Everything runs on sun power: cars, public transport, central heating and cooling. The sun may feel like your worst enemy during the day, but at least it helps keep you warm inside at night. The park looks nice from afar. Trees, bushes, green grass, and flowers. But everybody knows they aren't real. Unless plants are in a greenhouse, they're artificial. The daytime heat would scorch and dry them up. The blistering cold would freeze them overnight. You sit down on a bench and hear two old men talking about how different the world is today. The landscape changed so much. Ponds and lakes evaporated entirely within a few months. They reminisce about fishing trips, farms, and fields. Yeah, only desert animals made it through the shift. You can see coyotes, roadrunners, lizards, and scorpions if you head far enough out of the city. Camels have replaced cows and horses on every continent. 30 years of the new climatic era aren't enough for evolution to make any big changes, but people have already started to look different too. Skin is getting thicker and rougher to deal with the temperature fluctuations. Eyebrows are bushier to keep the sweat on your forehead from rolling down into the eyes. One of the old men looks at his watch. 7:30. We gotta skedaddle, Jim. It's 7:30 already? You've already wandered far from your house. You open your bag and dig for your pants, gloves, boots, and where's your winter coat? You keep digging. Panic rises in your chest. You start throwing things out of your bag, desperately hoping it's buried at the bottom. No such luck. You get a chill down your spine. Fear? Yes. But also because it's already cooling down. You throw all your stuff back in the bag and start sprinting down the street. 7:40. You're not gonna make it. At least the running is keeping you pretty warm. 7:50. There are no buses, no cars, no nothing. Everybody's already inside. 7:55. You know what's coming if you don't get home by 8. When it's minus 40 degrees and you're in your daytime clothes, it takes just 5 minutes for hypothermia to set in. You've heard the horror stories. People venturing out into the cold without the right gear on. First, the shivering, rapid heartbeat. Your body fights to keep you warm. Then the shivering stops. Heart rate goes down. You start to feel lightheaded. Your body gives up. When they pass out, that's it. 7:58. You see your street up ahead. Come on, legs, go faster. 8 p.m. The cold knocks the wind out of you. You're a minute from your house. Just keep going. The air stings your lungs. Your eyelashes get covered in ice. Your nose is bright red. Is this it? This is how you go? 8:01. You burst through your front door and fall to the floor. Made it. You open your eyes, and the first thing you see is your winter coat hanging on the back of your desk chair. You can't help but burst out in laughter at your carelessness. This day that started out so perfectly, yet turned so quickly, like day and night. I really do need that vacation. Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new superplanet out there. K2 414b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up, it's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the North and South poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm. That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm. and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright